200. Another way of viewing the complexity of Go is that the number of possible configurations of the board is more than the number of atoms in the universe.
With the MGT series, MAN Diesel and Turbo has created a family of gas turbines that it has developed at its Oberhausen site. The highly efficient MGT 6100 and MGT 6200 turbines set a milestone in the 6 megawatt output class. Let us look at the MGT 6200 first. It is a twin shaft model used as a mechanical drive for compressors, for example. The compact core engine delivers a maximum output of 6.9 megawatts. This is equivalent to 9,522 horsepower, thus as much as 95 automobile engines of 100 horsepower each produced together. The MGT 6200 basically comprises two sections. The gas generator with the compressor driven by the high-pressure turbine serves to take in and compress the air needed for combustion. Inside the 6 combustion chambers, the air is mixed with fuel gas and the mixture is ignited. The hot exhaust gases expand, driving both the high and the low-pressure turbines. Let's take a closer look at this process. Due to the spinning motion, the blades of the axial compressor strike the air. They conduct it into the turbine while compressing it in the process with the compressed air homogeneously, already before it enters the chamber. Afterwards, this mixture is ignited and burns with extremely low emissions. The fuel gas air mixture expands due to the combustion heat to many times its volume. As a result, it flows at high speed first through the 2 rows of blades of the high-pressure turbine and then through the low-pressure or power turbine, thus driving both shafts. The exhaust gases flow through a diffuser into the outlet casing. Their high temperature of around 460 degrees Celsius can still be utilized, for instance, to generate steam. The shaft of the power turbine can be operated independently of that of the gas generator in a speed.
Air. A lot of gaseous molecules floating all around us. It's great for breathing, and it turns out it's great for getting lights turned on. That's because air, along with abundant natural gas or other fuels, are the ingredients that combine in a gas turbine to spin the generator that produces electric current. If you follow the electricity you use at home or at work back through the power lines to your local power plant, you'll see that the process most likely starts with the work of the gas turbine, the very heart of the power plant. First, air is drawn in through one end of the turbine. In the compressor section of the turbine, all those air molecules are squeezed together, similar to a bicycle pump squeezing air into a tire. As the air is squeezed, it gets hotter and the pressure increases. Next, fuel is injected into the combustor where it mixes with the hot compressed air and is burned. This is chemical energy at work. Essentially, this is what happens in your family car's engine, but at about 2,900 times more horsepower. The hot gas created from the ignited mixture moves through the turbine blades, forcing them to spin at more than 3,000 RPMs. Chemical energy has now been converted into mechanical energy. The turbine then captures energy from the expanding gas, which causes the drive shaft, which is connected to the generator, to rotate. That generator has a large magnet surrounded by coils of copper wire. When that magnet gets rotating fast, it creates a powerful magnetic field that lines up electrons around the coils and causes them to move. The rotating mechanical energy has now been converted into electrical energy because the movement of electrons through a wire is electricity. In what's called a combined cycle power plant, the gas turbine can be used in combination with a steam turbine to generate 50% more power. The hot exhaust generated from the gas turbine is used to create steam and a boiler, which then spins the steam turbine blades with their own drive shaft that turns the generator. What you end up with is the most efficient system for converting fuel into energy. And that's your GE gas turbine 101.